Good day, welcome to Excellence Academy. For today, we are going to be considering an aspect called structural mechanics, how to find for reaction. If peradventure you are new to this channel, I will appreciate if you can click on the subscription button and like and also comment. Here is the easiest way to solve this problem under structural mechanics. If you observe this figure, it is a what? Let me show you the question to this figure. As you can see in front of you, the distribution of load in a simply supported beam is given in the diagram below. As you can see the diagram here. Determine the reaction at the support. We are told to do what? Determine the reaction at the support. Now, my first task here is I want you to get to note there are some two things in this question that we need to be familiar with. Number one is this reaction. This is a roller support, and roller support always have what? Only one reaction, which is what? The vertical reaction. But this is a pin support, or you call it hinge support. It has only what? Two reaction, the vertical and what? Horizontal reaction. So note these two. Secondly, what I want you to notice is that this load you are seeing here, this is called a uniformly distributed load. These two are called uniformly distributed load. This is a point load. Now, my first task says to make sure I convert these two into what? Point load, as something like as this one, this way. I need to convert all these two load to what? To point load. Now, the first task says let's draw our free body diagram. To draw our free body diagram, so to do this, now my first task is to take it this way. I want to draw my free body diagram. I'll take it down this way, right? So if you observe closely, this is a point load which is somewhere here, right? So I'll draw the point load here, which is what? Given to be 10 kilonewton. 10 kilonewton, right? Next up, here is called D. Here's my point D. Now observe, I will know this distance. This is a distance from here to here is 10 meter. Here to here is 10 meter. Here to here is 10 meter. Instead of putting it up, I'll put my own down here. You can do it anyhow you want it. Let me just put my own. Let me come here. Come in. So what I'm doing. Take it down this way. So let me just call this point here. This is my A, equal to 10 meter. As you can see what I'm doing. This point here, where it ends here, this point here, I'll call it point E. Right? Point E. This is my point E, which is this one. But on that point E, there is a what? A roller support, which has what? Only vertical reaction. We said it just now. A vertical reaction. So I'll call this what? R-E-Y. Why? It is called reaction at E on Y axis. Yes. So now I've converted this word to what? To a point load this way. This is a roller support, which is this. Now if you observe closely, from E to somewhere F is 10 meter. Let me call this point F. Point F. Let me call it point F. F. So distance from E to F is going to be, which is equivalent to 10 meter from the drawing, from the diagram. So if you observe, there's a distance from here to here covers a what? A UDL, uniformly distributed load. So if I want to convert uniformly distributed load to point load, something like this. Now observe something, please. To convert uniformly distributed load, this is how it goes. I'm given from here to here. Just focus on this and this. It's going to be what? 2 kilonewton per meter, which is what? 2 kilonewton per meter, right? Multiply by the distance from here to here is what? 10. 10 meter. Hence, meter cancel out meter. 2 times 10 is 20. Then I'm left with what? Kilonewton. Here is, I've simply converted this UD here from here to here to what? To 20. Now, this 20 will now become a point load. Now, where will I put it on this place? Hence, note something. Whenever you convert UDL to point load, it acts at the center of the distance. From here to here is 10. It acts at the center of the what? Distance. Let's call this is the center here, which is what? I'm giving 20 kilonewton. Hence, it simply means that I can say that, observe, I can say that since here to here is 10 and the center here, so it ends, here can become 5 meter, here can become also what? 5 meter, which is sum up to what? 10. I'm still correct, right? I'm still correct. So observe this logic here. If I convert UDA to point load, it's at the center of what? Of the distance. Also, this is F here. Let's move to G. G is somewhere at this point, right? G is at this point. But if you see, there's a pin support, and pin support always have how many reaction? Always have what? 2 reaction, a vertical reaction, right? The vertical reaction and the what? Horizontal reaction. Horizontal reaction. So what will I call this? I'll call this what? RGY. I'll call this RGX. Reaction at G on y-axis. Reaction at G on x-axis. So hence, if I have 4 kilonewton per meter, convert it to point load, that becomes what? 4 kilonewton per meter. Multiply distance from here to here is 10 meter. Cancel out this. I have what? 40 kilonewton. So hence, this point load will act at the what? Center. So put at the center of this point. Center is here. So I have 40 kilonewton. So it will act at the center. So if I take this one this way, I take it down this way, right? Since from here to here is C given to be 10. So here is what? 5 meter. Here is 5 meter. If I add them together, I'll have 10. It's still correct. So we have successfully converted all this stuff towards our free body diagram. So our next task now is that if you observe closely, we can solve this using what? The law of equilibrium, right? So using my law of equilibrium, I will have the following. So applying the law of equilibrium, applying the what? The law of equilibrium. So what will I be having? So if I apply my law of equilibrium, my first law says what? Summation of what? Horizontal component must be equal to 0. Summation of what? Horizontal component must be equal to 0. Hence, consider right force to be what? Positive, and left force to be what? Negative. Any force facing this side is positive. Any force facing this side is what? Negative. Hence, my summation H. Any force that is double laying, I mean lying down, right? This force is lying down. This one is vertical. This is only horizontal here. So hence, I'll be having what? RGX as my horizontal. This is equal to 0. That is all. In some cases, we don't even solve for summation H because we usually know that it's what? It always falls at 0 in some cases. So if I proceed, applying what? This is the first law of equilibrium. Second law says what? The summation of vertical components must be equal to 0. So consider upward force to be what? Positive, and downward force to be what? Negative. So note this, please. Now, it simply means I'm considering all the vertical here. I'm having 1, 2, 3, 4, 5. 5 vertical components. Let's start with this, REY. I will have REY, which is the first one. Going upward is positive. We said upward force should be what? Positive. So this is going upward, is positive. This is upward too. So that becomes plus what? RGY. So hence, come to this point, minus 10. Why is it minus 10? This is going what? Downward. And we said downward force should be what? Negative. So that becomes minus. Also minus 20. Also minus what? 40 is now equal to 0. Summation V is all this. Equal to 0 is equal to 0 here. Now, if I proceed mathematically, I'll be having REY plus RGY is now equal to minus 70 is equal to 0. Minus 10, minus 20, minus 30, minus 30, minus 40, minus 70 is equal to 0. So if I apply mathematical approach, I'll be having REY plus RGY is now equal to 70. If minus 70 plus equality sign becomes what? Plus 70, right? Becomes plus 70. Hence, put kilonewton. So call this equation 1. Call this what? Equation 1. So what is the reason behind calling something equation 1? The reason there is that you can't, if you are looking for two things on a same equation, and if I'm looking for REY and RGY at the same time, I can't look for them in the same equation. So hence you call it what? Equation 1, because you can't find two things in one equation. So let's proceed, please. If I proceed, I'll be having, we said the first law of equilibrium is what? Summation H is equal to 0. Second law is what? Summation V is equal to 0. The last law is what? Taking moments. Let's take moments. Taking moments at any point. So you can take moment at what? Any given point. But my advice here to every student is that always take moment at when you know that has two reaction. This is having two reaction, horizontal and vertical. So our advice to take moment at what? At G. Why? Because G has what? Two reaction. So taking moment at what? At point G. Hence that becomes summation mg is equal to 0. Moment at G is equal to 0. So consider what? What are we considering here? Consider what? Consider clockwise to be what? Positive. Then what? Anti-clockwise to be what? Negative. So now observe, please. Here is my own illustration on calculating for moment. If we take moment at this point here, it simply means that note something, please. Anywhere you're taking moment from must always be equal to 0. Any fucking where you're taking moment from, anywhere, that position, everything that surrounds that position must be equal to 0. So hence RGY is 0, RGX 0, RGY is 0. Why? Because we are taking moment at what? At this point. So everything becomes what? Becomes 0. Right? Becomes 0. So my next task now is that, having considered this to be 0, let's proceed. If I observe, we are taking moment here. Here's my own illustration of moment. If I'm told that they want, at this point here, they want to share 300 billion at this point here. This force here will be interested in collecting that 30 billion. This force here will also be interested in collecting that 30 billion. This man here too will be interested in collecting what? 30 billion. Also this man. Now, here's the idea, please. 40 kilonewton will come to this point to collect 30 billion. but it will move what in this manner, this way. It will move what in this way. And we know, you know that we are dealing with what? Moment. And moment is simply what? Force times distance. That's the formula for moment. Force times what? Perpendicular distance. Hence, I'm working with what? I'm working with both force and distance. So this is my force here. Trying to what? Collect 30 billion at this point. So the force initially was what? 40. But this is moving what? In a what? Anti-clockwise manner. Observe. Anti-clockwise manner. That's because of minus 40. So this distance from here to here is what? 5. That becomes what? That becomes minus 40 times 5. I have this, right? So plus into, I'm done with this 40. Move to this 20. 22 will be interested in 30 billion. It want to come to this point to collect 30 billion. So for it to now move, it will move what? In also what? Anti-clockwise manner, this way. It will move this way to this point. Hence, it is 20 multiply what? Distance from this point here. Observe, oh, this point to this point is 15. 5 plus 5 plus 5, that is what? 15. That becomes what? Minus 20. Minus 20 multiplying what? 15. I have this, right? I have this plus into, observe, into, let's proceed. I'm done with 40, I'm done with 20. Let's move to this point E. This is a support here, also trying to collect 30 billion. It will move what in this manner. Observe, it will move what in this manner. So this is manner is called what? Clockwise manner, right? A clockwise what? Manner. Hence, that is positive, which is what? REY multiply what? From year to year is 20. 5 plus 5, 10, plus 5, 15, plus 5, 20. So moving what? In clockwise, that becomes what? That becomes REY multiplying what? 20. I have that. Plus into, observe, into, my next task here is to take this one, D, it will move what in anti-clockwise manner, which is always what? Negative. So that becomes 10 multiplying what? From year to year is going to be what? 30. That becomes minus 10. That becomes what? Minus 10 coming. That becomes minus 10 multiplying 30. So I have this at this point. If I proceed mathematically, I will have minus 40 times 5 will give me minus 200. This is a positive sign. Into minus 20 times 15, that becomes minus 300. This is a positive sign. Plus what? 20 times REY. It's what? 20 REY. Please, if you put REY 20, you are still correct. But it is not making sense. Number comes before alphabet, which is what? 20 REY, right? So into what? Minus 300. I have this is now equal to 0 at this point too. So if I proceed, I'll be having minus 200 plus times minus is what? Minus 300 plus 20 REY minus 300 is now equal in value to 0. Hence, if I take this one, 20 REY to the other side, that becomes what? Minus 200 minus 300 minus 300 is now equal in value to minus 20 REY. Hence, I'll be having minus 800 is equal to minus 20 REY. How do I get minus 800? It's simply what? Minus 200 minus 300 minus 300, I have what? Minus 800. Hence, in mathematics, if you have minus in both sides of the equation, it's cancel out. Cancel out this, cancel out this. I'm left with what? 800 is equal to 20 REY. Hence, divide by what? 20. Divide both sides by 20. Right? Hence, I'll be having that becomes, let's say, 800 divided by 20 is equal to 20 REY divided by 20. This cancel out this. My REY mathematically will become 800 divided by 20. So hence my REY now, my REY is now equal to 800 divided by 20. I will be having 40 what? Kilonewton. Here is my value for my REY. Let's get the value for our what? RGY, because we have two things there. Observe, we have REY and RGY. So we have gotten REY. Let's get RGY. So recall from equation 1. So you can just let us it here. Recall from equation 1 that says what? That says, what's my equation 1? This is my equation 1. Let me show you. This is my equation 1. Is this? That becomes what? REY plus what? RGY is equal to 70 what? Kilonewton. So put what? We said put REY, which is equal to what? 40 kilonewton. I mean, at this point, this man here, this one, we got this one, this value here, put it into that equation 1. REY, put this value into equation 1, which is this. So REY now is 40. That becomes 40 plus REY, RGY rather, is equal to what? 70. I'm looking for RGY. That becomes RGY is now equal to 70. This comes out as that becomes what? Minus 40. So hence my RGY, my RGY is now equal to 30 kilonewton. Here is my value after solving this problem. So I have two values. RGY is equal to 30 kilonewton and also REY is equal to 40 kilonewton. If you have found this class helpful, do not forget to click on the subscription button and like, share to your friends and classmates. Thank you and welcome to Excellence Academy. Thanks for watching.